Hey everyone, in this video we're going to be looking at Chapter 2 of Pragmatic Programmer, which is called a pragmatic approach. This chapter has some tips and tricks that are almost always going to be applicable to your day-to-day life as a coder, starting with the essence of good design, which is the foundation for the other topics in the chapter. The other topics include things like why duplicating code is so bad, orthogonality, and prototyping. So without further ado, let's move into the first section, Essence of Good Design. What is the hallmark of good design for software? The hallmark of well-designed software is how easy it is to change. Being able to change is of the utmost importance because change is inevitable. Not only will you be changing your own code in the future, but others will be as well. So it's important that you and others have an easy time of doing that when the occasion arises. There are a few ways that you can make your code easy to change. Probably the most important one is making components or otherwise functions/chunks of behavior as small and as single use as possible. Then, once they are made, give them names that are very explicit in telling what they do. The small components and functions are the more opportunities there are for naming, and thus more opportunities to convey to your future self and others what behavior is going on inside the function. Keeping file lengths short is also a good practice. I try to keep my files under a couple hundred lines for the most part, and if I notice that a component or utils file is getting too long, I'll take that as a cue to split it into smaller files for better comprehensibility later. The next section is called The Evils of Duplication, and I can tell you for sure duplication is indeed extremely evil. It's time-consuming, it's unnecessarily confusing, and proliferates vectors for bugs to show up. There's even the danger that duplication belies some sort of institutional rot within a company. One example of this that comes to mind is when a team doesn't want to share code with another team, but instead forces the second team to make a copy of their original code so that they don't have to help with maintenance. I've seen this more than once in my career, and it seems to basically stem from mistrust of the other team and a lack of willingness to be helpful in any way. The problem with duplication is that when an interface changes in one place, the downstream effects are felt in not just one or two, or in not just one, but maybe two or more places, depending on how many times the one thing has been duplicated. This leads to an issue where the owners of the original source might be aware of the downstream effect in the first place and make adjustments as necessary, but wouldn't know about the subsequent place, and so that case will break. The authors have a great quote in here about something they call DRY, which is an acronym for Don't Repeat Yourself. If you have to remember where you made changes in multiple places, the question won't be whether you'll remember where those changes will be, but a matter of when you'll forget. So dryness isn't just a caution against copying and pasting code, but also of copying and pasting intent and knowledge. When you have code that's technically different, but does largely the same thing, what signal is that sending to yourself and others in the future? How will you know which code is relevant to subsequent changes? The answer is that a lot of time you won't, and so confusion will abound in terms of knowing where the source of truth is, which will then spiral out of control given enough time. The next section in the chapter is called Orthogonality. This word, and a couple others, remind me of a quote from a TV show called The Good Place, where one of the minor characters says, "What a fun way to say something totally normal." That's the case with orthogonality as well. It's a fancy way of saying that the components of systems are independent enough from each other that they can change individually without breaking how they interact with each other. For example, a UI will change independently of a database, and the database can be changed without impacting the UI. When you're building products, it's vital to make everything as independent as possible and have a well-defined interface that has the buy-in of everyone. If things are too closely coupled together, then there's a huge risk that someone will make a change that seems innocuous, but that will break something elsewhere unintentionally and possibly invisibly for some time until it's discovered. Next is a section about reversibility. This is essentially referring to the concept of being able to walk back from a decision or set of changes made as the project progresses. When your code is dry, decoupled, and uses external configuration, you have the freedom to make as few irreversible decisions as possible, and the cost of changing any particular part of the project is minimized as well. The second reason that reversibility is an important characteristic of good software design is that even when a product is done and released to the world, it isn't really done, and there are never any final decisions, since the program will continue to be extended with new features, refactored, and so on. The particulars of what individual decisions will need to be reversible are up to you and the various aspects of your project, but when making decisions, it is worth asking yourself how hard it would be to take back if you change your mind, or if the circumstances you're operating are changed and you have to take it back. The next section is called tracer bullets, which is an interesting visual. Tracer bullets are, in the literal, non-metaphorical sense, I should say, bullets shot from a machine gun that leave a trail of ignited chemicals as they go downrange, which serves as a visual cue to the shooter that bullets are or aren't hitting the intended target, which in turn allows the shooter to adjust the aim accordingly, if applicable. So to bring that visual over to the world of engineering, the authors give this concept of, quote, code that glows in the dark. What's meant by this is just coding through the golden path of new behavior that makes it all the way from one end of the project to the other and through all the layers in between. This might entail a front-end UI aspect, a database piece, other server pieces, and so on. Once you have that happy path taken care of, you know that the basic premise is complete, and from there you can move on to handling the edge cases and bringing the feature to the level of robustness and completeness that it needs to be. This approach contrasts to prototyping, since prototyping is more of creating a proof of concept that will likely be discarded before the end of the project. By contrast, with tracers, you're exploring possible paths that illustrate how all the pieces of a program are connected together, and you'll ultimately still use one of those original solutions that are created. We'll illuminate this difference more in the next section, which is about prototypes. Prototypes are useful in the early ideation phase of building a project, but shouldn't be confused as fully formed products, as compromises are intentionally made along the way to disqualify it from being a long-term solution. The upside of building a prototype is that you can more quickly demonstrate a functionality to your teammates and other stakeholders, but the downside is that in exchange for fast iteration speed, you almost always have to make quality compromises to enable that. So there are a few different categories that you can compromise on for the sake of this early iteration speed. And they are correctness, completeness, robustness, and style. For correctness, that means that you can use dummy data in some places, rather than having to do an entire end-to-end API with real data. You can hard code, for example. For completeness, this means that only the basic functionality needs to be done for the sake of the demonstration. The third piece, robustness, means that things like error handling, adding tests, and other corner cases are punted on for the time being. Finally, by, quote, style, the authors mean that you can leave out documentation, comments, and other ancillary pieces that usually accompany what we consider thoughtfully designed and constructed programs. So that's all for this video. I hope you found it helpful and thought-provoking, and I'll see you all in the next one.